Hi, welcome to my video on find the value of k using the roots that's going to be real or imaginary, equal or unequal. Find the value of k for each quadratic equation. Notice in number 1 we have the equation k x squared plus 8x plus 1 equals 0 if the roots are real and unequal. Well, if d is greater than 0, then the roots are real and unequal. If d is equal to 0, then the roots are going to be real and equal. And if d is less than 0, then the roots are going to be imaginary and unequal. So when they say the roots are real, equal, imaginary, we're talking about the discriminant. So if the roots are real and unequal, that means that the discriminant in the quadratic equation is greater than 0. And your discriminant is equal to b squared minus 4ac. Therefore, b squared minus 4ac is greater than 0. If d is greater than 0, d is equal to b squared minus 4ac, then b squared minus 4ac goes right here, is greater than 0. So we have an equation. So we have a is k, b is 8, c is 1. So we'll put b is 8, so we put 8 in. A is k, and c is 1 greater than 0. So we'll solve this inequality. So 8 squared is 64, and we multiply next by PEMDAS. We have a negative 4k greater than 0. So negative 4k is greater than negative 64, and we divide by negative 4. And when we divide by a negative, the inequality, that becomes a k. Negative 4 divided by negative 4 is k. Dividing by negative 4 changes the greater than to a less than. So we get k is less than 16. So all values of k that are less than 16 put back in this equation. It could be a 15, it could be a 14, and any number less than 16, the value of the discriminant here will be greater than 0 and giving you real unequal roots. Number 2, we have a quadratic equation, x squared minus 2kx plus 16 is 0. And we want to find the value of k if the roots are equal. So let's look up here. If the roots are equal, then d is equal to 0. So d is discriminant, so d equals b squared minus 4ac. So that means b squared minus 4ac is equal to 0. And a is 1, b is negative 2k, and c is 16. So we'll sub that in. We got a negative 2k, and we have to square it, minus 4. A is 1, and c is 16. So we'll sub that in. Negative 2k times negative 2k is a 4k squared. And 4 times 16 negative is negative 64 equals 0. We got 4k squared equals 64. Divide by 4, and we get, move up here, 4's cancel. I get k squared equals 64 divided by 4 is 16. And if k squared is 16, then the square root of k squared equals plus minus the square root of 16. So k is equal to plus or minus 4. So if you put 4 in here, then your discriminant will be equal to 0, and you'll have equal roots. If you put a negative 4 in the place of k to get the negative 8, then your roots will also be equal, and your discriminant will be 0. Number 3, 3x squared plus 6x minus k equals 0 if the roots are imaginary. And if the roots are imaginary roots, then d is less than 0. And d equals b squared minus 4ac. So therefore b squared minus 4ac is less than 0. And a is 3, b is 6, and c is negative k. So b squared is 6 squared minus 4. A is 3. C is a negative k less than 0. So we have 36, and we got a negative times a negative is a positive. 3 4s are 12k less than 0. So 12k is less than negative 36. Divide by 12, and k is less than negative 3. Notice I'm dividing by 12. When you divide by a positive number, the inequality stays the same way. That's less than stays less than. And so all values of k less than negative 3 put in here. It could be negative 4, negative 3.5, negative 5, negative 6, negative 7. Any value of k less than negative 3 placed in here, then your discriminant will work out to be a negative number. And let's continue. Again, notice we're using the math, but the math is based on what the roots are and the values of k fitting in. Good exercises. Find the value of k. Number 4, x squared plus 4x plus k minus 1 equals 0 if the roots are real. First of all, a is 1, b is 4, and notice that's x squared and x, so that means that c is k minus 1. If the roots are real, so real roots happens when we have d greater than 0 and d equal to 0. So that means d is greater than or equal to 0 for real roots. So d equals b squared minus 4ac. Therefore, b squared minus 4ac is greater than or equal to 0. So b squared is a 4. B is 4, so we squared. A is 1, so we put a 1 in. C is k minus 1, greater than or equal to 0. We square first, we get 16. And now we have to do PEMDAS. Remember, we do the exponent first, then we multiply, and then we add or subtract. So negative 4 times 1 is negative 4. So that gives me negative 4 times k, negative 4k. Negative 4 times negative 1 is a positive 4. And we have negative 4k plus 20 is greater than or equal to 0. That means that a negative 4k is greater than or equal to negative 20. We divide by negative 4, and they cancel. When you divide by negative 4, the greater than becomes a less than, equal to, and that's a 5. So any value of k that's equal to 5 will give you real roots. The equal to 5 will have your discriminant 0. If it's less than 5, like a 4, a 3, a 2, a 1, negative 1, etc., and you put that value of k in there and work it out, then your roots will be real also. And number 5, k squared minus, x squared subtract kx plus k equals 0 if the roots are imaginary. And again, if the roots are imaginary, that means d is less than 0. So d is equal to b squared minus 4ac. So therefore, b squared minus 4ac is less than 0 because we have imaginary roots. So a is 1, b is a negative k, and c is k. So b is a negative k. So we put a negative k in. A is 1, put 1 in. And c is a k, so we sub that in. Less than 0. So we square first. Negative k times negative k is k squared. And we multiply next. We get negative 4 times k is negative 4k. less than 0. Now notice you have a quadratic in this inequality. But let's factor this. So we have k is factored, GCF, greatest common factor is k. K squared divided by k is k. Negative 4k divided by k is negative 4. So we have an inequality, and how do we handle it? Well, here's what I do with inequalities. I draw a number line, and I have, notice that if you think about being equal to 0, k is a 0, or k minus 4 is a 0. So 0, k is a 0, or k is 4. So look on the number line, we have a 0, and we have a 4. Okay, so how does it work? Well, what you do is that you have numbers that are greater than 4. You also have numbers that are between 0 and 4, and you have numbers that are less than 0. So which numbers will fit? Well, let's take a 5 and sub 5 into this inequality. Let's put 5 in. Let's let k be 5. So here's the inequality. I'm going to put 5 in for k and see if it works. So 5 times 1 less than 0. 5 less than 0, no. So we can't go above the 4. So let's go in here between 0 and 4. Let's take a 2 that's in between. So let's say k is 2. And we write down the inequality again and see if it fits. K is 2, k is 2, and we go 2, we work out the bracket first, we get a negative 2. And when we go 2 times negative 2 is negative 4 less than 0. That's true. So if you take a 1 or a 3 or a 3.5 or 1.7, any number in between will be true. And what about the number that's below this? Let's see. What about if we take k as negative 1? Put a negative 1 in the inequality that we have at the end. Let's see if it fits. So k is negative 1. K is negative 1. Negative 1. Negative 5. Less than 0. 5 less than 0. No. So the values that fit this equation that are going to be imaginary must be the numbers between 0 less than k less than 4. It has to be, it's not equal to, so it's the numbers that you can't have 0 or 4 that'll make it equal to. It got to be less than, so it's these two. And another way to name that would be that open, and it would be a 0 open with a 4. That's the interval. So you could have 0 less than or equal to k less than 4, so it's all the values between 0 and 4, or it could be this interval. So notice the inequality, how you work them out. Because if you have 0 and 4, less than is the numbers between these two. If you had a greater than right here, it would be greater than 4 and less than negative 1. So you're either above the 4 and below the 0, or you're in between. Okay, number 6. X squared add on k plus 3 times x plus 1 equals 0. The roots are real and unequal. Real and unequal roots. So real and unequal roots, that d is greater than 0. D equals b squared minus 4ac. So that means that b squared minus 4ac is greater than 0. And a is 1, b is k plus 3, and c is 1. Notice the k plus 3 is the, let's pretend that k is 5. 5 plus 3 gives you 8, so b would have been 8. So k plus 3 is the value, goes with x. So there's a, x squared, plus bx plus c, so b is k plus 3. So k plus 3 is your b, a is 1, and c is 1, greater than 0. Now we have k plus 3 being squared, so that's k plus 3 times k plus 3. And I'll just expand that out, but not do anything yet. Now I'm going to do FOIL on this. So k times k is k squared. K times 3 is 3k. 3 times k is 3k. 3 times 3 is 9. And we multiply all this together, and we get a negative 4 greater than 0. And we simplify, we get a k squared plus 6k. Oh, that's a plus 9 now. Plus 5 is greater than 0. 3 times 3 is 9, but I forgot to put the plus in. So 9 minus 4 is 5. Again, we got a quadratic. That's factorable. Okay, let's factor it. K squared is k and k. And this is the product of 5 and a sum of 6. So the factors of 5 are 5 and 1. And because the product is positive and the sum is positive, I have 2 pluses. So that means, if you think about it, k, we look for the boundary, the values of k that's going to give you the 0. And we let each of these equal to 0 like before. So we find that k is negative 5, or k is negative 1. So we, just like we did a while back, right here, I'm going to take these two numbers and put on the number line at a negative 1. Oop, let's put a negative 1 right here and a negative 5 here. Put them in the right order. Negative 1 is on the right, negative 5 is on the left. Okay, now we got, so I have a greater than. So as I said before, an inequality that the A coefficient, there's no negative here, I'll clear it. If you, greater than, when you have the A positive, then greater than is going to be on the above the negative 1 and below the negative 5. If this was a less than, then it would be in between these two. But let's check it. Let's take k to be negative, let's see, let's go below. Let's go with a negative 6 and see what happens. Let's put the negative 6 in this inequality right here. So I have k plus 5 bracket k plus 1 is greater than 0. K is negative 6, so we put a negative 6 in. We just take our time and see what happens. Negative 6 plus 5 is negative 1. Negative 6 plus 1 is negative 5. And so negative 1 times negative 5 is 5. 5 is greater than 0, so this number is okay, so we're allowed to be down here. So all numbers below negative 5 will work. Negative 7, negative 8, etc., etc. And let's take a number between negative 5 and negative 4. Let's take a negative 3. So what happens when k is negative 3? So let's write the inequality. K plus 5, bracket, k plus 1 is greater than 0. And k is negative 3. So I'm subbing in negative 3 for k. Negative 3 plus 5 is 2. Negative 2. Negative 3 plus 1 is negative 2. Greater than 0. Negative 4 greater than 0. Nope. So none of the numbers between negative 5 and a negative 1 will fit this inequality. And what about when k, pick a number above? Well, we got negative 1. Let's pick a 0. The 0 is above it. Let's pick k to be 0. That's a good number to put in. So k plus 5, k plus 1 is greater than 0. K is 0. Put 0 in. 0 in for k and see what happens. 0 plus 5 is 5. 0 plus 1 is 1. 5 plus times 1 is 5. And 5 times 1 is 5. 5 is greater than 0. That's true. So again, the numbers, notice, if you think about it, we're not allowed to have negative 5, but we're allowed to go below. Like that. We're not allowed to have negative 1, but we're allowed to go above negative 1. So notice the hollow dot is not included. So there's the shading. And by the way, up here, the shading would be not 0 because there's no equal sign, not 4 because it's not 0 and 4 because there's no equal sign, but it's in between. So there's the shading of the numbers that represent the values of k. And so how do I write this down? Well, you're allowed to go k is less than -5, or k is greater than -1. So we're not equal to, k is less than -5, and k is greater than -1. So how do we represent that? Well, we can represent that by an open -5, and we got to go the other way, so that's -infinity. Or we can have k is greater than -1, so it's a bracket, open bracket, and -1. And where we go greater, if you go to the right, you go to positive infinity. So there's the two interval notations that represent this. And again, I repeat, if the value in front of the k squared is positive, then less than will be in between these two numbers when there's a quadratic. And if k, again, the a in front of the k squared, if this value is positive, then greater than will be above and below the numbers. So that's a little bit of extra practice solving for k when the roots are real, imaginary, equal, and unequal. And these two examples here relating to the quadratics is a little bit of extra math that I threw in. So if you like my video, click the like button, click the subscribe button, click the notification bell, and visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. I just want to, just before I leave, just want to draw your attention. These two questions here is pertaining to inequalities related to the quadratics, and that's a unit that I'm going to do after this one, how to solve these inequalities with a quadratic, because I have a whole unit done on solving inequalities, less than and greater than, when it's linear, but I got another unit to do on when they're quadratics. Thank you very much for viewing my video. Bye-bye.